Welcome to number systems. Before we get into all the different types of number systems and a couple different properties, you have to understand what the numbers are. We can classify the numbers. We have many different classifications. In Algebra 1, we're going to talk about real numbers. In real numbers, we have what we call rational numbers and irrational numbers. Irrational numbers are decimals that never end and have no pattern. An example of an irrational number would be 22 sevenths, which is the same as pi. It never ends, and it has no pattern to it. Another one would be radical 2. If you calculated radical 2, it has no end, and it has no pattern. Everything else are rational numbers. Rational number, let's start with the smallest number. These are 1, 2, 3, 4, and so on. These are called your natural numbers. There's no decimals, there's no fractions, and they start at 1. Then we have numbers that start at 0, 1, 2, 3, 4, and so on. No decimals, no fractions. These are called your whole numbers. Notice the difference between your whole numbers and natural numbers is your whole numbers, color this in here, have 0, where natural numbers do not have 0. And then we have -4, -3, -2, -1, including 0, 1, 2, 3, and it goes in both directions. These are your positive and negative whole numbers, or otherwise known as integers. They have no decimal, no fractions, just positive and negative whole numbers, including 0. So where do we put our numbers, our fractions, like 3/4 or 0.50 or I don't know, 6/10 or radical 49 or radical 100 or even 1/2. These we would just classify as natural numbers. Let's go ahead and take a look at an example. If we had 5/22 It's not a natural number, 1, 2, 3, 4. It's not a whole number because it doesn't 0, 1, 2, 3, 4. It's not positive, negative, or 0. So our only choices are rational or irrational. And when we divide, if you were to divide it, let me go ahead and bring up my calculator here. And I plugged in 5 divided by 22. Hit the equal sign. Notice it says 0.227272727272, and this 3 is because it's rounded. That means it has a pattern, so it's a rational number. If I had the number 3, the number 3 falls under natural numbers. It falls under whole numbers. It falls, therefore, it's an integer. And therefore, it's a rational number. And everything's a real number that we're talking about, so we don't have to say it's a real number. Let's take a look at another one. Negative radical 9.16. I'm going to bring up my calculator again. And we hit clear. And 9.16, the square root, notice there's no pattern. 0, 2, 6, 5, 4, 9. There's no pattern. Well, first of all, it's negative. And it's tough to tell on a calculator, but this never ends. So therefore, this would be negative 3.0 and so on. It never ends. This is an irrational number. Okay. If we have, let me do one more. If we have, where's the space? Radical 81. And we're going to plug that into our calculator. Hit clear. And put the square 81 in the square root. And bring this down. Okay, let's do that again so you can see. 81, the square root is 9. The answer to that is 9. 9 is a natural number. It is a whole number. 9 is also an integer, and therefore it's under the umbrella of a rational number. Or you could just say it's a rational number. Okay, let's go on to the next page. Let's talk about the closure property. In the closure property, if I had an example of, sorry about that, let me go ahead and erase it and try that again. If I had whole numbers and multiplication, I would pick two numbers, multiply them because the operation's multiplication, and I'd solve. Is 12 a whole number? Yes, it is. Let's try 5 times 2. I selected 2 whole numbers. I multiplied. I got a whole number as an answer. Okay? What this means is whole numbers, when I multiply whole numbers, I get whole numbers as an answer, so therefore whole numbers are closed in multiplication. It will work every single time. Let's try whole numbers and subtraction. I pick 2 whole numbers, 3 minus 2, and I get 1 as a whole number. But what if I said 2 minus 3? That gives me negative 1. Negative 1 is an integer, not a whole number. So therefore, whole numbers are not closed in subtraction. Okay, now what if we graph number systems? When graphing real numbers, let's take an example. I have fractions. I have a negative 4/3, which is a rational number, negative 1/3, which is a rational number. Fractions can't be integers, just rational. 2/3 and 5/3. And now I have a number line. Let's try and make this number. That's not going to work on a number line. Nope. Okay, I'm going to have to do my best to draw a number line, which my hand's not very straight, so bear with me. Okay. And I have the numbers 0. I always put 0 in the middle. 1, 2, 3, leaving, those are my whole numbers. Remember, 1, 2, and 3 are my natural numbers. 0, 1, 2, 3 are my whole numbers. And then if I add negative numbers, those are my integers. Okay. Now I'm going to graph these numbers here. These numbers are fractions, so they go in between your whole numbers and negative numbers. Negative 4/3. I have to divide. I have 4/3 and 4.00. Top number falls in. 3 goes into 4 once. 1 times 3 is 3. Subtract. Bring down my 0. 3 goes into 10 3 times. 3 times 3 is 9. 1. Subtract. Bring down my 0. Okay, so this is going to repeat over and over and over again. So it's 1.33 repeating. This is a rational number because it does repeat. I look at 1, So I start at 1, 1.5 or 1.5 would be right there. So 1.3 would be right somewhere right there. So it'd be negative 4/3 right there. Now negative 1/3. Negative 1/3, once again, this is 1/2. Okay. If I were to pull up my calculator and calculate 1 divided by 3, I'd get 0.3333. That's repeating. That's a rational number. It doesn't quite make it to 1/2 or 0.5, so it'd go right here of negative 1/3. Let's take a look at 2/3. 2/3 is between 0 and 1. I know that because the numerator is smaller than the denominator, so it always goes between 0 and 1. If the numerator is larger, then we take a look at and divide it when we divide it at what it is. So I'm going to pull up my calculator and plug in 2 divided by 3 equals 0.666. Okay, I know if this is my halfway point, or 0.5, 0.6 would be right here, so that would be 2/3. Now let's take a look at 5/3. Remember I told you when the numerator is larger than the denominator, it's going to be after 1, and we have to divide to make sure at where it's at. So if I said 5 divided by 3, that would give me 1.66, so I know it's between the 1 and the 2. And this would be 1.5, so 1.6 would be about right here, or 5/3. These are all rational numbers. Okay, let's see if you can graph an inequality. Let's go on to another page. Make it as straight as possible. It's a good thing I'm not a doctor. I don't have a even hand. Okay. What am I going to do? I'm going to put my 0 in the middle. 1, 2, 3. I always go out 3 points in both directions, unless I have to go out more. Okay. My problem is x is less than negative 2. Notice on my greater and less than sign, I don't have a line underneath, so I'm just going to circle the negative 2. And I want my x to be less than negative 2. Remember, the point always points toward the smaller amount. So I want my line, which I'm going to highlight, I want my line to be less than negative 2. Sorry about that. Okay. And then I'm going to put an arrow, because I can plug in any number that's less than 2. That will make this sentence work. Let's try another one. What if x is less than or equal to 4.5? And draw my number line. I have 4.5, so I'm going to start with 0, 1, 2, 3, 4, 5. Okay. 4.5 is between 4 and 5. See this little line underneath? That means I need to color in my dot because 4.5 can be included. And all my numbers, I don't know what numbers they are going to be less than 4.5. So I can get my highlighter. I'm going to highlight all numbers as straight as I can. You guys probably have rulers. I don't. Less than 4.5 or equal to 4.5. Okay, let's talk a little bit about square roots. Square roots. If I said I have a square and it's a 2 by 2, that means 2 going this way, 2 going that way, or I could say 2 to the power of 2, which means 4. If I had a square and I said it was 3 by 3, or 3 squares by 3 squares, I have 3 times 3, or 3 squared, which is 9. Now, if I were going to take the square root of 4, I'd get my base of 2. That's my base. Okay? If I were to take the square root of 9, I'd get my base of 3. And what the square root means is what number times itself will give me 4. That would be 2. Since I have a pair of it, I take that out. If I were to say the square root of 49, what number times itself will give me 49? 7 times 7. Since I have a pair of 7s, I can take that out. And that's my answer, 7. Let's go ahead and take a look at some examples and how we work them. If I had square root of 64, which means a number times itself, which is 8 times 8. I have one pair of 8s, so my answer is 8 because I took out a pair. Okay? If I have negative radical 64, it's just a radical sign, or the square root of 64. The negative's on the outside, so my answer is going to be negative. And the square root of 64 is 8, so my answer is negative 8. If I have a plus minus square root of 64, I already know. Well, let's take a look. The plus minus sign is on the outside, and the square root is 64, and the radical 64, the square root of 64, as we know, is 8. My answer is plus minus 8, which technically means a positive 8 and a negative 8 for an answer. Let's take a look at negative. How would you do negative radical 49 over 256? Well, first I have a negative. The square root of, I have a fraction inside. The square root of 49 is 7, and the square root of 256 is 16. You can double check on your calculator that. And so therefore my answer is negative 7/16. What about this one? Plus minus the square root of 4 over 121. Well, I have my signs, plus, minus, and then I have 4 over 21. The square root of 4 is 2, and the square root of 121 is 11, because 11 times 11 is 121, and the square root of 4 is 2, because 2 times 2 equals 4. Try this one. Radical 1.69. I don't know that one off the bat. I know 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and you keep on going. I know those by heart, but I don't know my decimals. So I'm going to grab a calculator, and I'm going to clear it, and I'm going to plug in 1.69, and yours has a square root symbol, mine has SQT, and I get 1.3. So my answer is 1.3. Notice you can double check yourself and make sure you're right by saying, because the answer times itself will give you what's ever inside your radical. If I said 1.3 times 1.3, I'm going to get my answer right back. Let's go ahead and try and put these in greater and less than by comparing. Go on to the next page. Give me some room. Pull up my calculator, because I'm going to need my calculator for this. Okay, what if I said radical 19 compared to 3.8 with a line across it? What that line means is that 8 goes on forever and ever. So it'd be 3.88888. Well, rather than writing that, I just put a line over it, and they want to know which one's larger or which one's less than. So I'm going to go to my calculator. I have to determine what radical 19 is, and the square root of 19 is 4.35, okay, and then I have 3.8. All I have to do is look at my whole numbers in this case. And now you're just comparing 4 and 3. 3 is less than 4. Remember, the arrow always points to the lesser amount. Okay, let's take a look at another one. If I had 7.7 2/10 repeating compared to radical 52. Pull up my calculator. I need to know what radical 52 is. 5, 2, the square root is 7.21, where this, remember the line means 7.22 repeating. In this case, I have the 7s are the same, the whole number is the same. The Tens place is the same, and now I have to look at the hundredths place. And as you can see, 7.21 is less than 7.22. Let's take a look at one with a fraction. 2 2/3 compared to radical 5. 2 2/3 is 2.2/3 on a calculator means 2 divided by 3, which is 0.666 repeating. Okay, and radical 5 or the square root of 5 is 2.23. Sorry, 2.23. Now, my whole numbers are the same, 2 and 2, so I look at my tens place, 6 and 2, and I ask myself which one's smaller, because that's the way I'm going to point the arrow. And that's all there is to it. And you would do the exact same thing when ordering them from least to greatest amount. You would change them all to decimals and then arrange their decimals. Okay? Thank you for watching Number Systems.